Hi, my name is Vincent, and I am a machine learning engineer over at Explosion. In this video, I would like to discuss the task of data deduplication. The issue around this topic usually involves a dataset, like this one, where some of the rows of data aren't exactly duplicates, but for all intents and purposes, they should be merged. Things like typos and spelling errors are typically not valid reasons to hold entities separate in a database. And data deduplication issues tend to arise very frequently. Governments, financial institutions, and large online stores, they all tend to deal with this issue every day. And you can imagine how multiple user profiles on a website might appear if there's a spelling error or a typo, even though they should definitely belong to the same person. And similarly, you can also imagine that you might have a product catalog with duplicate items in them merely because the description text is just a little bit different. And the thing is that if you get data quality wrong on this level, then you can imagine that any recommenders that follow might certainly suffer from data quality issues. Another common situation is that you might be dealing with a large database with your client information, but that you might have one on the regional level and another one on the national level. Both of these different databases might need to get merged at some point, and even if the regional and the national office don't have duplicates in their own data, there might still be duplicates between them. So also here you would have a data deduplication issue where you would have to link up some records. Now, a very interesting aspect of this data deduplication problem is that while it's a very important problem that many businesses face, it is also a problem that's very hard to solve without a human in the loop. And that's why, in this video, we are going to try to tackle this problem by leveraging Prodigy. Prodigy is an annotation tool made by us over at Explosion, meant to help data professionals get started with meaningful machine learning projects by allowing data professionals to label their own data themselves. A main feature of Prodigy is that we can fully customize the experience with our own Python code. And that means that nothing is stopping us from using our favorite machine learning tricks while we keep the human in the loop. And that means that we're able to do clever things on how we label. We won't need to waste time going through every single one of these examples. We can also just spend our time finding examples that are likely duplicates, and we can send those over to Prodigy. The goal of this video is to start from scratch and to show you a pragmatic approach on how you might be able to tackle a data deduplication problem yourself if you were using Prodigy. And that means that we won't just show you how you can customize the Prodigy interface for this task, but we'll also demonstrate some other tools from the data science landscape that can be used to improve the Prodigy experience as well. I hope you're excited about this, so let's get the ball rolling by talking a little bit about the data set that I'll be using in this video. So I'm inside of Jupyter Lab over here, and I have a dataset loaded. This dataset comes from a Python library known as recordlinkage. And recordlinkage is a library that's got some heuristics to find duplicates in data, and I would argue in general it's a likable tool. But one of the main features that we'll be using in this video is that it actually comes with some simulated data that you can use for benchmarking. Now I want to mention up front that this is definitely a simulated data set, so we kind of have to keep that in the back of our minds. But it does resemble a use case that is somewhat plausible and might be relevant to something you might see in a typical business use case as well. So what I'm doing is I'm loading in the load feber L2 dataset. And what I'm also saying is that I want the links to be returned as well. And this will give me a data frame that looks like this. And the index that you see over here, that contains the link information. So theoretically, we could use that to confirm whether or not we have found duplicates. But for this entire video, I will just ignore this column. But again, it's good to stress that this is indeed simulated data. Now, given that we have this data set, what I always like to do up front is just try to think a little bit about the domain and try to figure out if we can understand why certain duplicates might appear in this data set. So let's discuss a few things. First of all, we have a given name and a surname in here. And these are names, so we should imagine that there might be some misspellings, some of which might be phonetic. So just for example, if you are named Chris, phonetically, if you're English, you might think this is how you might spell it. But if you're Dutch, then you can also spell Chris with a K. So phonetically, we've got an interesting scenario here where the way something sounds doesn't necessarily imply how it's spelled. So, this can be a valid reason why we might get some duplicates. Now, another thing to keep in the back of our minds is that if this is a data set that was collected by using writing, and let's say that some OCR technology was used here, then a lowercase g and a 9, they're actually quite similar. So this can also be a reason why a typo might appear, especially if this was like collected with a questionnaire or something. Another thing that we might see in this data set is just that we have missing values. So that might be a thing to keep in the back of our mind. We might get an entry where the street number isn't filled in, for example. Another thing that I'm reminded of is that sometimes the given name and the surname, they can be flipped. And that can cause lots of issues, and it's actually something you see quite commonly as well. And now that I think of it, that can also definitely happen with these street addresses as well, not just the first name and last name. Another thing I want to just briefly highlight is that we also seem to have a date here, this date of birth. And it seems to follow a numeric standard where it's probably year, and I think then month and then day. But we should keep in the back of our minds that in general, date values can adhere to all sorts of formats. We might suddenly have the day first, and then the month, and then the year, and it kind of depends on where you are on the planet to what the ISO standard norm is. So that's also something that could cause some duplicates to appear. Then we also see the social security number. Social security numbers are a sequence of numbers, but it is quite common that two numbers that follow in sequential are flipped. So yeah, all of these reasons for duplications are to be expected, and some of them are reasonably well understood. And I always think it's just good to spend a little bit of time thinking a little bit about the domain, because it helps us come to an approach perhaps. Now, before moving on, there's one thing that I would like to do though. So this data frame, I can ask for its shape. And this data frame has, it seems, 5,000 rows. And although that doesn't sound like too much, we should consider that if we're going to go look for duplicates, we need to compare all 5,000 of those rows with all the other rows in this data set. And if I were just quickly to put that in a math formula, we might be expected to check this many combinations if we want to do everything by hand. So even though 5,000 rows isn't that much, certainly checking for all the combinations between those rows, that is a huge number. So that's not something we're going to be able to do manually. And again, to emphasize, we only have 5,000 rows here. That's a small number for an average database with customer data. If this was 1 million, then this number would have exploded even further. So we are going to need to do something that's just a little bit more clever than checking all the examples by hand. And this is where the record linkage library is able to help us. So record linkage comes with a couple of mechanics to deal with finding duplicates, but one very direct mechanic that we can use is the concept of blocking. Now, the way that that works is you're able to give it a column name. In this case, I'm saying just give me the given name. And then we're going to only compare combinations where the given name is the same. The thinking here, if I were to compare this row with this one, is that we don't have to compare every single row, because a Sarah and a Jacob, well, odds that those are the same people is just very small. We are only going to be comparing Sarahs with other Sarahs. And if we do this, then the set of all possible combinations to check just reduces immensely. If we just introduce this blocking trick, then there are way less candidate links for us to concern ourselves with. Only 55,000 or so combinations, so that's a huge improvement. But 50,000 is still too much to check by hand, So we would still like to take those candidate links and reduce that down even further. And record linkage also has some tricks for that. So we have this candidate list that's already a smaller set than what we started with, but we're able to reduce it down by defining a couple of comparisons. The thinking here is that we might be able to say, well, let's only look at examples where we have Sarah. Then within this group of everyone being Sarah, we can now start wondering, well, when do we have reasons to believe that there might be a duplicate? So one thing that we could do is we could say something like, well, if two addresses are similar, if those two strings are alike, so to say, then that could be an argument for a duplication. And I can do that with a bunch of these columns. And record linkage also comes with a set of features that allow you to define these reasons. And record linkage likes to call that a comparison or a compare object. And here you're able to just define a couple of reasons of similarity. You can use string similarity, which is what I'm using for the surname and for the address. And string similarity in this case might mean Levenstein distance or a Jarrow-Winkler similarity. The idea basically is that we have string similarity metrics, and that once we cross a certain threshold, we can say, that's a reason for a duplication. But we are also able to say, well, there has to be an exact match. So for example, a rule that I have over here is I'm saying if the state is exactly the same, okay, that's also a reason why we might have a duplicate. So what I've done is I've just started by saying, well, I've got 4 reasons of similarity defined over here. And this is by no means meant to be exhaustive, just a starting point. But what I am able to do is I am able to say, well, given that we have these reasons, I can now take my original candidate links and I'm able to reduce that down even further. I'm able to do something like, hey, if out of these 4 reasons, at least 3 of them are telling me, yes, it's a duplicate, then let's consider those examples. So this approach is, you could argue, somewhat standard and basic, but what I really like about this approach is that it's kind of rule-based and very well understood. And it should give us a meaningful starting point. And if I have a look at all of these examples, and if I scroll down just a little bit, then we can see all sorts of combinations. These are the indices from the data frame, and we can see which rules are being applied. But moreover, the thing that I see is that when I make this final reduction, that I'm then left with 822 rows to consider. And this is a really nice position to be in. 800 rows is something that is somewhat manageable. So that means that our exploration work has been fruitful, and that what I can now start doing is I can start moving these candidates into our Prodigy annotation tool, just for me to confirm if these duplicates are indeed sensible. But I also think that by moving to Prodigy now, I'll also be able to just have a look at the data and maybe learn from it as well as I'm labeling. So the next step would be for me to set up a Prodigy project and to customize it for this problem. Now, before immediately diving into the custom code for this specific problem, I figured it would be good to first highlight some of the moving parts of a Prodigy project. So what I've done is I've gone to the main Prodigy website, and from here what I will do is I will go to this live demo just to showcase the different elements inside of Prodigy. So this is what the Prodigy interface typically looks like. There's a little pop-up here that reminds us that this is a demo. But in general, Prodigy works by listing an example that you can label in the center over here. And this is an element of UI that typically is a bit interactive. In the case of named entities, I might be able to select a little bit of text that I can assign a label to. And typically, there are specific elements for specific labeling tasks, like this named entity use case over here. But the way it works is you interact with an element, and then you can say whether or not it's correctly labeled. So I can say, yes, this looks good. And then this example is considered labeled, and I can move on and keep labeling. But I'm also able to say, well, this is a rejected example, or this is an example that I skip. You're also able to sort of move back an example if you want to redo your work. But in general, this is the Prodigy interface. There's the thing you want to label in the center here. There's a bar below here that allows you to move forward, backward, etc. And there's a sidebar over here with some extra information. Now, there's a lot of examples here that we could explore, but the one example that I think is somewhat similar to what I'd be interested in is this single choice text example over here. And the way that this works is you just see some text over here, and then that text needs to be assigned a label, which is either this one or this one. It's a choice between two options. In particular, the demo here showcases the Quora duplicate question use case. So you have to select the sentence that is the most like a duplicate that is shown here. But if I were to pull apart this interface, then I would say that there are two main elements. There is this element on top over here, and this other element below. And to me, at least, it seems very nice to have a choice here, such that I can choose between two options. But instead of having text here on top, I think I want to change that to some custom HTML. And in particular, for this deduplication use case, I think it might be nice to generate my own custom HTML table. Maybe something that looks a little bit like this, where I have a name, a surname, and some other columns that are of interest. And then below this, I will have a choice menu such that I'm able to say, hey, this is a duplicate or not. So what I would really like to do is just take my long list of candidates and turn each combination of candidates in a table effectively like this one, such that I can just very quickly, one by one, start labeling them and get an impression via this interface. Now, as luck would have it, this tool is scriptable. So nothing is stopping me from using my own favorite Python framework to render these HTML tables. And in fact, we can also go back to the main Prodigy website. And from here, we can go to the Prodigy documentation. And here, you're able to find lots and lots of guides on how to set up Prodigy and customize it to your liking. But the part that's going to be of interest to us is this bit over here, the part that explains custom recipes. Now, in Prodigy, a recipe is nothing more than a Python-based definition of what you would like to happen within Prodigy. Plainly put, a Prodigy recipe really is just a Python function with a specific output that can be run from the command line in a specific way. And if we scroll down in this guide over here, we actually see a pseudocode example that'll help us understand what parts we need to implement. So just to briefly zoom in, what we see here really is a definition of just a single Python function, but it comes with a decorator around it, one that is provided by the Prodigy library. Now, one thing to observe is that we have a function here with a specific output. We have a dictionary with specific keys and values. But the main thing to observe first is this decorator, because it's this decorator that allows us to run this function from the command line as well. If we scroll down just a little bit further, we get an impression of what it might be like to run this from the command line. And you can see that you have to call Prodigy, then a name that's attached to the recipe, followed by a data set and some extra parameters that we can pass in. But it's this decorator here that actually allows us to do that. So how does this decorator work? Well, we need to give a name to this recipe. That's the first argument of this decorator over here. But then things that follow are actually inputs for the function below. So we have a dataset parameter that is passed in the decorator, which we can pass through. But similarly, we also have a view ID that's passed below here. By having those defined in this recipe, we are also exposing that to the command line. So that means that we're able to reuse the same recipe, but maybe for different datasets, let's say. Now, moving on to what's actually inside of this function over here. And in particular, let's zoom in on just the output dictionary over here. The first thing that you need to output is a data set, which is nothing more than a name for Prodigy to store your labels in. All of the labels that you produce will eventually go into one bucket, and we have to have a name for that bucket, put plainly. And that's what this dataset parameter is. And you'll notice that it's passed through and it's passed through, which again means that we can reuse this recipe also for different datasets, which is nice. We can tweak that from the command line. Then there are two more items that are required, which is this view ID and this stream. Now this stream over here is basically a Python list or a generator. The pseudocode is over here. And basically this describes a long sequence of Python dictionaries. And these dictionaries need to contain all sorts of information that can be rendered inside of a user interface element. Which user interface element is actually being rendered? Well, that's something that we set with this view ID parameter. As we saw before, we might have named entity recognition, which has a different view ID than just a basic choice. But the idea is that if we combine these two things together in the right way, that then Prodigy is able to render the element of our choosing. And we're able to configure this in such a way that what we're actually rendering is custom HTML. The main thing we got to do is just make sure that the appropriate information is being passed onto this stream over here, but for that we can use custom Python code. These are the things that you must implement inside of a recipe, but you can also define some extra things, like for example this update callback. This will allow you to run some Python code once we get a batch of annotations coming in. And this can be very useful. Maybe you want to do some custom logging, but it's not something that we will need for our use case. But it is good to know that you can customize your experience further if you would like. With this little introduction out of the way, what I would now like to do is just show you how I built my own custom recipe for the deduplication task. Okay. So I am now inside of Visual Studio Code, and I have a little project here that contains everything I need for the data deduplication use case. I have the notebook that I had open a little while earlier, but at this point there are three main files that deserve just a little bit of extra attention, and that is the make file, the basic.py file, and this HTML file. So I'll just zoom in on that to keep the screen real estate clean. And the first file that I think deserves some attention is this make file. Now, make files are pretty useful. What they allow you to do is they allow you to have a command like make clean. And if I were to run make clean in this case, there is a correspondence between the clean option here and the clean definition in the make file. And effectively that means that if I run make clean, that then I run these lines of code in the terminal. And that's just kind of nice, because this way I don't have to remember all of the lines of code that are defined here, and instead I can just try to remember make clean, which is usually a much easier thing to do. Now, if you're using spaCy, then odds are you won't be using a make file, but you're going to be using the spaCy projects file instead. But because I'm not using spaCy here, I figured a make file will be good to have. So one area where having these commands is super nice as well is in the installation phase. This allows me to just install this on a new machine. And I'm upgrading pip. I am installing everything in my requirements.txt file. So the record linkage tool, for example, will be in there. But what I'm also doing here is I'm installing Prodigy. And you'll notice that I'm using pip in order to do that. Now, this is a likable trick, I think. So what you can do is you can install Prodigy manually. But what you can also do is you can point pip to a custom index, one that is hosted by Prodigy, and then you can install it programmatically. The only thing you need to do is you need to make sure that your license key is in the URL over here. And because my Prodigy key is saved in this environments variable file, I can ensure that I get my key injected here, which is nice because that way I don't share my key with everyone on the internet. But the main reason why I'm doing it this way is just because it saves me a manual step. I like to automate things. Now, the main command that we will use most in this makefile, though, is this Prodigy basic command. It will just run the basic recipe that I've made for this one little use case. And just like we mentioned before, there's a couple of parts. So we start with the Prodigy command, and next we see duplicate over here, and this will be the name of a recipe. And again, a recipe is a Python function with a decorator, and that Python function can be found in the file that's mentioned over here. But we're also passing some other information. We are also passing the name of the data set to save all the labels into. But I'm also passing an extra parameter, namely this one, which is also in the recipe definition. And this is a JSON lines file that is on disk. It's a file that I prepared off screen in my Jupyter notebook that contains all the candidates that I would like to consider inside of Prodigy. It contains all the data that we need in order to render the user interface inside of Prodigy. So let's give a quick preview of that as well. So what I can do is I can type head-1 to show the first line in the data record linkage items.jsonl file. And here you can see that this one line actually does contain valid JSON. And what I'm just going to go ahead and do is just pipe that output to JQ. That's a command line interface that just gives me a little bit better colors. And again, this is a single line in this file, but you can see here that there are two items that I would like to compare. Both these items are for the name Sarah, and if I squint my eyes just a little bit, I can see that the thing that's making these two just different is the fact that the address has a character that's different. This one has a space and this one doesn't. So that explains why this might be indeed a good candidate for a duplicate. But what my recipe is doing inside of this make file over here, that is making sure that an example like this one is actually turned into a nice HTML table inside of Prodigy. But the code that I have defined over here needs to make sure that the examples in my JSON-L file get rendered appropriately. So let's now have a look into that file now. Right, so now I am in the basic.py file, and you can see over here that I have a recipe defined. You can recognize that because I have the Prodigy recipe decorator around a function called checkDuplicate, and this function also returns the dictionary that Prodigy needs in order to render what we want it to. Now there's a couple of things to point out. First, the name of this recipe is duplicate. Next, we also see that we are passing in a data set as a first parameter, and that this data set is also passed in the output that we see over here. Now the next bit is a little bit more interesting, because what we're also passing along is that file path, the one that contains the JSON-L file with all the items that we would like to match. What I'm doing is I'm using this helper from Prodigy, this JSON-L function, and that is going to take that file path, and that will output a stream of information that I would like to label. Now this stream represents a continuous stream of Python dictionaries, and as we saw in the file, we have the first item that we would like to compare, as well as a second item that we would like to compare. But it deserves to be said that at this point in the code, this blob of data does not have all the information that Prodigy needs. In this particular case, we are using the choice as a view ID. And that means that items in the stream also need to supply choices that we can pick from. Now, these choices are added in this add options function, which is defined below. Now, inside of this add options function over here, we are looping over every single element in the stream in this for loop. And inside of it, we are saying, well, let's set the options equal to this list. So that means that before the dictionary enters the function, this is what it might look like. But after, we also now have an options key attached, and that is pointing to the list of options. And we are also passing some HTML. That's what this add option function over here is doing. We are making sure that some extra items get attached, and because we are attaching these items, we are able to add the options that this view ID needs, but we are also able to add some extra HTML and that is going to render our nice little table for us. Now, this HTML over here is an actual Python string. It's just rendered HTML. And what I'm doing is I'm using a library called Jinja2 to actually handle this rendering on my behalf. I am using a basic.html template that Jinja is loading in, and then I'm filling it with information from this dictionary. I'm referring to the item 1 key and to the item 2 key to render this template. So let's have a quick look at that template. The template is just a HTML file, but with a couple of these curly mustache bars to indicate that we can fill in some information. And this is just Jinja syntax. By writing it down this way, Jinja knows how to properly render this. I've added some minor CSS styles as well, just so the table renders in a pretty way. And I've also added this h2 element just to emphasize what the task is. And mainly we're saying like, hey, are these items similar? And then if I look back at my Python file over here, then I can see that from the options that we can pick from, we can either indicate that it indeed is a duplicate or that they are unique. And note, I've taken a little bit of extra effort. I'm definitely using emojis over here. I think that's going to make the labeling experience just a little bit better. But this is it. This is the Python function that has our custom recipe inside of it. So that also means that this is the function that is being run from the command line over here in my make file. So that means that if I were to now go to the terminal, and if I were now to type make Prodigy basic, that Prodigy will now start up. It will use the JSON-L files that I mentioned before, and it's using the recipe defined in this one little file. There is one final thing, I suppose, that is worth mentioning in this case. You'll notice that it's pointing to a specific port number and to a specific IP address, and those settings are in a separate prodigy.json file that is in the root of my directory. So these settings are configured here. But what I can now go ahead and do is go to my browser, point it to that address, and when I do that, I get an interface that looks just like this. I get the are these items similar prompt. I get a nice little table. It has item 1 and item 2 inside of it. And I also have these two options that I can pick from. Either it's a duplicate or it is unique. And because Prodigy comes with some sensible defaults, I'm also able to not just use my mouse cursor, but I'm also able to use the keyboard to select the choice that is of interest. So in this case, because the address 1 over here just seems to have a minor typo, I'm very comfortable saying that this is indeed a duplicate. And from here, what I'm going to do now is just start labeling some examples. And if I see an interesting example, I will stop and just observe what I'm seeing. But already this is a nice interface, and I like the idea of being able to just iterate quite quickly with Prodigy now. So I'll do some labeling. So right now, I've been labeling for a bit. I have almost 50 examples labeled. And just from doing this, I seem to have learned a couple of interesting lessons. So one thing that I've noticed as I've been labeling this is that there's actually a little bit of cognitive load in performing the task. So for example, in this case, what's the difference? I mean, is the social security number different, or maybe the suburb or the address? Or it takes a while for me to spot the difference, only to maybe find out after a while that there's just a little typo here in the surname. So that is making me think that perhaps I can improve the labeling experience by just adding a little bit of color here. I like to think that in doing so, it'll be a lot easier to just spot the difference. And I can certainly imagine that's going to make it just a little bit easier for me to label accurately, but also to label a lot more quicker. Now, there's also another thing that I've noticed. By far, most of the examples that I have here are duplicates. I've taken the effort to only look at examples where it's plausible that there is a duplication happening, and I've noticed that I just don't need to hit this other choice so much. And with that in mind, I also kind of noticed that I can hit 1 now, and then I still need to accept that this is indeed the correct label. So I can do that by hitting A. And although this works, I do need 2 keystrokes in order to perform the labeling. And considering that by far most of the examples are going to be duplicates anyway, I think I don't need the second keystroke. So that is also something I would like to address to make the labeling just a little bit better. However, there's also this other phenomenon that I saw a couple of times, and I'm going to label a bit further now to see if I can catch another example of this one phenomenon. Ah, yeah, so here's another culprit of that. So notice in this case that we seem to have a typo in the address over here. And I can argue, sure, that might be a reason for duplication, let's merge that. However, what I also see over here is something that's just a little bit suspicious. It seems that the social security number isn't just a little bit different, it's way off. And the thing with social security numbers is, if it's a completely different social security number, but it has like the same name and it might be a duplication, I mean, sure, it depends on the use case, but this can indicate fraud, potentially. And I might argue that if this were a real-life use case, then I would like to treat these situations just a little bit differently than mere duplications. I might want to raise a flag here that says, hey, this is sensitive for fraud, so extra attention needs to be taken into account in this example. And that is making me consider that perhaps I should add another option here. Maybe something that says double check. So I'm happy that I'm doing this exercise, but I'm even happier that I'm also reflecting as I'm labeling here, because with just these few observations, I think I can improve the flow quite a bit. So I'm going to make some changes to the recipe to reflect some of my lessons. Right. So I am back in Visual Studio Code now, and I have made some small changes. In the make file, I have added an extra command. I have Prodigy Basic now, but also Prodigy Intermediate. And this intermediate.py file contains a new recipe, one that's better than before, although it deserves to be said that the changes aren't drastic. If you have a look at the recipe, there's only a few changes, really. So in this dictionary that I return, I have now also added a config setting that allows me to add some extra settings to the Prodigy experience. And the main setting that I've added is this choice auto accept setting that's now set to true. And this will make sure that whenever I hit either duplicate or unique, that I don't have to press accept afterwards in order to see the next item to label. And that should make the labeling just a whole lot faster, so that's a simple setting that I added. Another thing that I've done in this add options function is I've added just another option. Before I only had duplicate and unique, but what I've done now is I've also added this double check thing that we can select. And that's going to make sure that we have some way of adding a flag for something that's just maybe a little bit suspicious. I figured that distinction was important to make, so I added that option over here. And then the last change that I've made is I have made a change in the template that I'm using in Jinja. The change isn't huge. The main thing that I've done is I've added this highlight class. The idea is that there's some logic in this one line over here, namely if the given name in the first item is the same as the given name in the second item, then I'm going to attach this CSS class to this element, and that CSS class is basically doing nothing more than changing the background color. So that means that if there's now a difference in the column in the table, that is just going to be highlighted. And I think that's just going to make labeling a whole lot easier for me. So yeah, those are the only changes that I've made. So if I were now to type make Prodigy intermediate in the terminal, then Prodigy starts up again. And if I were then to go to the browser, then this is the new experience. We can see that there is a new item called double check that's been added. And we can also definitely see that there's some highlighting happening here. And that's kind of nice because now I can clearly see that, yeah, there's a spelling error in this column, but there's also a minor one over here with the C and the CT, and there's also a minor one over here. And that's just a lot easier to spot now, which is great. So in this case, I want to say that it is a duplicate. So if I were to hit the number 1 now, Then I also no longer have to hit the accept key, so I don't have to press A or hit this green button, which is nice. And as a final thing, something that is also nice about this is I can also clearly see, hey, the social security number is different, which is an interesting prompt for me. And also very quickly here I can say, hey, that's just way off. This is a little bit suspicious. So let's hit button 3 now, because this needs to be double checked. So again, we are dealing with simulated data here, but I will say that the flow that I have is definitely very nice. I can come up with interesting candidates in my Jupyter notebook using whatever trick I like, and I've customized the labeling experience such that I am quite effective. So I'm actually quite happy with the current setup right now. And I also think that this is a nice point in time to wrap up this video. So let's summarize some of the things that we've learned. So here we are. We have a workflow that allows us to take a large pool of potential duplicates, turn that into a subset, which we can then pass into Prodigy so that we can confirm if 2 items can be merged. It's an approach that, as is, can already save a whole lot of time, but I also like to think that the current setup is just a very nice milestone. We're definitely able to keep the human in the loop, but it's also very easy to iterate on our way of working going forward from here. Looking back though, I do think that there are a couple of lessons that deserve to be mentioned explicitly. For starters, we took the time in the beginning to explore the data before actually working on a solution, and I like to think this was a really good move. Jupyter seems to lend itself just very nicely for quick exploratory work, and being able to take the time to just reason a little bit about the task as well as about the data, that was just a very meaningful exercise. It certainly helped shape my understanding of the problem, and I like to think it's something worth repeating. Secondly, we are currently using a rule-based system provided by the record linkage library to find potential duplicate candidates. And looking back, I think this was a great starting point. It gave us a system that was very easy to understand, and it gave reasonable results very quickly. While it's not the most state-of-the-art approach, it certainly felt like the right choice looking back, mainly because it keeps things pragmatic. Then, when we started labeling, we didn't just annotate examples. By labeling and looking at the examples one by one, we actually spotted a potential for fraud. And by being exposed to the data, we were able to redefine the task in a very meaningful way. And I wonder that we might not be able to learn this very important lesson if we don't have a human in the loop. Furthermore, we were able to customize the Prodigy experience, and I think it's advisable that you reflect on the experience as you're labeling. In our case, we were able to very much improve the experience by just adding a background color to our HTML table. But I think in general, you're able to make substantial improvements on both label quality as well as the speed of labeling, but just reflecting very frequently as you're labeling. I suppose a final lesson, looking back at everything, is that this entire setup wasn't a whole lot of work. The project has a Jupyter notebook and a Python script that contains the recipe for Prodigy, and yeah, maybe a config file and an HTML template, but it just took me an afternoon to set everything up. And that's a pretty good return on investment in terms of time spent. Now this was partially because we kept things simple, but also because Prodigy handles a lot of the boilerplate for you. Now, as much as I like the current setup, I think it's also good to maybe just mention a few interesting avenues for improvement. For starters, we are currently using a rule-based system, and it's been able to generate about 800 or so candidates, most of which we were able to confirm seemed like good duplicate examples. So that's good, but we might want to try out some other rules as well, mainly because we might be missing out on some candidates if we just stick to this set of rules. And as a prime example, I think it might be good to not just block on the given name in our CSV file, but that we should also maybe consider doing that on the social security number. We definitely still want to keep a human in the loop to ensure that we don't assign bad duplicates, but definitely there's some iteration that we can do on these rules. Thinking beyond these rules though, we might also consider a more machine learning or statistical approach. The goal here isn't to replace the rule-based system, rather to come up with something that can complement what we already have. The thinking here is that there might be duplicate patterns that are very hard to capture with rules, And it's certainly possible that some of these patterns are more easily captured with a more numeric approach. What's also good to keep in the back of our minds is that given enough examples and labels of duplicates and non-duplicates, we might also consider an active learning approach, which is a feature of Prodigy. We might be able to train a machine learning algorithm that can detect whether or not two items are duplicates, and we can train such an algorithm as we are labeling. And this approach might also allow us to find examples that the rule-based system cannot detect, and we can also use this machine learning algorithm to sort the pairs of candidates that we should look at first. Finally, another thing worth thinking about is that currently we are just labeling pairs of duplicates, but we haven't really talked about the process that needs to follow after. If I think about the problem, it might be the case that some of these pairs of duplicates are actually part of a duplicate triangle. So in a more real-life scenario, we'd probably want to think about what kind of post-processing needs to happen here in order for us to also deal with these collections of duplicates that need to be merged into a single entity. Now, I very much like the current project, so we might explore some of these next steps in an upcoming video, but I hope that the video as is has been a worthwhile demonstration on how you might be able to customize Prodigy for the data deduplication task. I think it's very important to keep the human in the loop in data science projects, and an annotation tool like Prodigy really provides a pragmatic experience. Having said all this, thank you for listening, and if you're interested, you'll find a link to all the code in the description box below.